Thank you, Brian. Thank you, Brian, for giving us this opportunity to share our research with you folks. I would also like to thank all the attendees for taking time off to hear a few of the stuff which we have been doing in the past 7 years. So with that being said, I would like to acknowledge my co-authors, in this case, all of them being my students, because I have been taking their research to present some of the materials today. First, I would like to give you an overview of what I will be talking about. We will be starting with forestry practiced in the state of Maine. It's a bit unique, and I will be explaining why it's unique. After which, I will be getting into the harvesting methods adopted in the region, and followed by which we'll be getting into study sites. We have 7 studies which were conducted, and I will be giving you a brief description about what the study was and what the objective was and what the stand conditions were. Then from there, we will be getting into the cost and productivity of doing different silviculture prescriptions using different equipment systems. Towards at that point, I will be shifting my gear and I will be getting into best management practices adopted in the region. I would like to state here itself that best management practices, or BMPs, are not mandatory for the state of Maine. However, if things get wrong, that can create legal issues. Towards the end, we will be getting into residual stand damage. And here again, I'm going to be presenting some of the results which we got. And the comparison is going to be between different harvesting methods and different silvicultural prescriptions. So without ado here, let's get into the state of Maine. It's the largest state within the New England region. And uniquely, the state is the most forested state in terms of percentage in the country. Would like to again reiterate, it's in terms of percentage, not area-wise. So when talking about Maine, I just want to first show this slide saying that about 90%, more than 90% of the silviculture in this region is partial harvest. Roughly 6% falls for clear cut. And the reason for that is because we heavily depend on natural regeneration. So that's why we go usually 90% of the time we go for partial harvest. And now that is unique for this region when you compare to the rest of the country. Now, let me get into the productivity and cost of timber harvesting for various silviculture prescriptions. Now, before getting into that, let me first, to make sure that all of us are on the same page, I would like to talk about harvest methods. Now, when you hear the word harvest method, what it refers to is in what form the tree is brought to the landing. Now, if it's a whole tree operation, the whole tree is brought. And this is the most common one, not just for the state, but for the whole country. I'm not really sure what's the situation in Canada, but for the United States, whole tree operations are the most common. You have a fellow buncher followed by a skidder, and the processing here is done at the landing. The second system is called as a cut-to-length system, and this is usually done for, most commonly done for partial harvest. And here the processing, the felling processing happens at the stand, and it's usually done by a harvester. And the processed wood is brought to the landing by a forwarder. Now the forwarder at the landing, the wood is just then loaded onto a truck. The third one is called as a tree length operation, and it gets a little bit, the whole tree length operation is a unique situation here, at least in this part, where it's a semi-mechanized operation. Usually chainsaw felling processing begins at in the unit, and then when the trees are brought to the landing, it's semi-processed or else tree length, and at the landing, the final bucking or merchandising happens. Now, I would like to bring in 2 more systems, which is called as hybrid cut length and hybrid tree length. Very unique system found in this part of the region. I mean, it's there in Canada, Quebec, in that region, and in Maine. Now, the difference between a hybrid cut length and a regular or conventional cut length is, in a hybrid cut length, felling is usually done by, felling is done by a fellow buncher, and then processing is done inwards by your harvester, and then it's carried back to the landing. Now, why is it unique? This the whole purpose of doing a hybrid cut to length is because it minimizes the damage done to the residual stand, especially the regeneration. It is expensive, however, it protects your natural regeneration. The same thing applies to a hybrid tree length, where the processor usually works in the stand rather than at the landing. The intention, as I said here, is again to reduce residual stand damage. Now let's get into the study site. I'm going to go. Go over. I'm going to go over the operational period. So the study was, all these 7 studies were done between 2016, and the blue one, as you could see in the map, that was the one which was latest done. This was done in last year, December. The prescription varied for different study sites. It varied from diameter limit cuts to crop tree release, to overstory removal, to clear cut. So there was a whole lot of prescriptions there, and the stand conditions also varied. I have listed the common, all the harvesting methods which were used for conducting the operation. With that being said, let's get into data collection. It was a detailed time and motion study which was done to collect the delay-free cycle time, and I've shown a table of which were the elements or variables that were collected. Regression models were later developed to find the most influential predictor variables. The volume of the wood removed were either received from the scale tickets or from log scaling. Machine rate information was directly collected from the logging company or the contractor which did the job. Now, I would like to spend a moment here, and this is how we basically calculated the cost. So you have the figures in the shapes in oval and gray. Those information came from the detailed time and motion study done out in the field, and the dashed rectangular box were information on the volume which came from the from log scaling or the scaling ticket. You could also see that the machine rate information were the oval white one. Those came from the contractors. Getting into the cost and productivity, I would like to just show a general picture here. You could see that the whole tree operations were much, whole tree clear cuts were the least in terms of the cost of operation. When it came to partial harvest, it was much more than your clear cuts. And again, the cut to length operations were much expensive than your whole tree operation. Now, I would like to kind of like put this in context. The reason why clear cuts were least expensive is because the amount of wood which was generated from a clear cut was much higher compared to that of a partial harvest. When it came to cut to length, I'm going to be showing that in the next step why this goes up. But let's talk about tree length for a moment. You might see that it's $136. The reason for that was tree lengths are usually done at it's a small woodland owner operation. What that means is that wood being generated is usually less. So as the denominator gets lesser, the numerator goes up, which is the cost. Now, I would like to shed some light into the cost of these machines. You could see that a cut to length operation, which is your harvester and a forwarder, this is way above $1 million in investment. So the cost of machine increases means that the cost of operation also increases. And comparatively, your cut to length operation is much slower than your whole tree operation, which again adds on to the cost. This is a comparison between partial harvest and clear cut. As you could see, clear cuts are much lesser compared to your partial harvest. We kind of just went over the reason. The reason here is much more wood is being generated in your clear cut. Now let's talk about the implication for management, and I'm going to just give a 30,000 view here and a feet view here. And so what I'm going to say here is that clear cut operations were much easier to execute. Partial harvest, it involves a whole lot of activities such as marking the trees. You need to implement the skid trails. Again, you need to take additional attention should be provided to the residual stand. So that's again something which makes partial harvest a little bit more complicated operation than your clear cut. In terms of the cost of operation, we just covered it. The point here is more volume of wood being generated means lower the cost of operation. Now I'm going to share another study, and here we are comparing an early commercial thinning with a group selection. Again, the early commercial thinning proved to be lesser. I'm sorry, the other way around. The early commercial thinning was a little bit more expensive than a group selection because in your early commercial thinning, again, you're not getting merchantable wood. The idea here is to improve the stand condition. So with that being said, folks, let's switch gears, and I would like to get into best management practice. As I said earlier, best management practice, it depends on the region or the state where you work for. In this state here in Maine, it's not mandatory, and So best management practice in this region at least means trying to protect the water and the soil quality, and it's usually done by laying a layer of slash mat on the ground. So here in this particular study, what we tried to enumerate or evaluate was the cost of this BMP to implement BMP, and we kind of like put that on the skidder. So we figured out that the extra amount of time that the skidder is spending on the slash, the processing residue, taking it back to the unit and laying it on these wet point, that was what we considered to be best management practices. And as you could see that the best management practices here, PH stands for partial harvest and CC stands for clear cut. It was really a function of the extent and intensity of the wet spots within the stand. And as you had more wet spots or fragile soil in your stand, the BMP cost increased. So it had a direct relation there. Now, folks, let me get into my last portion, and this is on residual stand damage. As you could see, all the studies which we have been talking about are published, and it is out there. So in this study, we were focusing on what is the residual stand damage under different silviculture and harvesting methods. So in terms of silviculture, we had three silviculture prescription, and we had 2 harvesting methods. That's your whole tree and your cut to length. So with that being said, there was a lot of data being collected, and we'll be talking about a few. The first one was what type of damage was it the damage to the ball or the main stem, or was it to the canopy, or was it a root damage? Another type of information that we collected here was the GPS location of the tree, at where, the vertical height at which the damage was found, and the DBH and the intensity, the severity index of the tree. I'll be talking about that in a second. So basically, it was a systematic transect. There were 5 transect 10-meter wide laid on the stand, and this is how it was replicated. And we also used 2 stands as a control, and in the control stands were not harvested. So talking about the study site, 2 of the study sites were, we had 2 study sites. One was in northern Maine, that was study site 2, and one was in southern Maine, which was study site 1. And let's talk about the prescription. We had a diameter limit cut. We had an overstory we had a crop tree release, and then we had an overstory removal. For study site 2 in northern Maine, the overstory removal was not there. Talking about the stand condition, it's worth to note that the acreage did differ between the study sites and between the stands. Then so was the basal area. There was a significant difference between the study sites. So I just want to let you know in the beginning itself, this cannot be an apple-to-apple comparison. In terms of residual stand damage, now let's get into the results. Most of the damages were to the ball or the main stem. As you could see, the canopy and root damage was much lesser. In terms of the severity index, this was a visual estimate it was done by a visual estimate, and you see it depended on how much cambium was removed, and this is again, I wanted to state that this is a visual estimate which we did. Now, coming into the results, I would like to say we normalized the number of wounds per hectare because, as I said, the stand area was different. You could see that there was a clear trend of lesser stand damage, residual stand damage for study site 2, which was a cut-to-length operation. I'm sorry, a hybrid cut-to-length operation. Compare that with study site 1, which was a whole tree operation. However, we did not really see a trend among the silviculture prescription. I would also like to point out that for the cut-to-length operation, hybrid cut-to-length operation in study site 2, the damage was much higher compared to that of whole tree. Now, as the damage gets lower, the chances of the tree to die or mortally injured is going to go up. With that being said, I also wanted to show you that the severity index was much lesser for your cut-to-length operation. So I think I'm still on time. I would like to kind of conclude the residual stand damage. The intensity of harvest affected the residual stand damage, which means the higher amount of trees were removed, more damage was there. Bolt damage was the most frequent, and again, it occurred right next to the skid trails. Hybrid cut-to-length had lesser damage density and severity index compared to that of your whole tree unit. With that being said, folks, I would like to thank you, and please feel to type in any questions. I am going to be giving the stage to my next co-presenter, Libin.
Okay, so I hope you can see my first slide. So my name is Libin. As you have already got an introduction for me, I will just jump right into my presentation itself. So I will be presenting on small diameter tree aspects of Northeast. So we conducted a study in the Northeastern Maine where it looked into the cost and productivity of harvesting small diameter trees. And I will also be presenting on the cost and productivity from a meta-analysis point of view. So which is a global level study that we looked into previous 20 years of harvesting cost and productivity reported in the articles and draw like overview inferences based on that. So before going any further, I want to introduce you to small diameter trees, which will be referred to as SDTs throughout the presentation. With that, I will be referring to trees that are smaller, less than 12.7 centimeters in diameter at breast height, which is a major component in woody biomass. In the Northeastern context, it is very important because we have a very high proportion of small diameter trees in the stand based on the national inventory data. However, if you look into a global scenario, it is a really major challenge for forest managers in terms of economic as well as ecological risks of management. In some regions or in many of the European or other countries, there are implications for producing energy components from woody biomass, which are low-value products, but on the other hand, increasing the efficiency and important for sustainability. This aspect is gaining a huge potential or interest in the global market in the past decades. Even though we have like a really huge impacts and the significance, the applicability, especially from a Northeastern context, rely on various aspects of the geography, the location, the management, like the stand conditions, the policy, the markets, and a whole lot of factors. The rationale for so these two chapters are part of my thesis, which I conducted. So the first rationale was we already have a huge data on the higher proportions of small diameter trees in the stand, as well as there is a need to identify the potential areas to ensure the continuous sustainable supply of materials for the biomass market. The first study we did was the first study I'm going to explain here is a published article in the Current Forestry Reports in 2022. So it's recently out from the press, and it's published in the Current Forestry Reports. It's available online. I'll try to limit my results and discussion to most important aspect, but always remember there are much more detailed explanation for all the studies, which I'll be happy to discuss if you have any questions. So the objectives of the study were to identify, so timber harvesting costs and productivity are influenced by a whole lot of factors, which involves the silviculture management, like machine, productivity, stand, and tree level factors. So the first objective was to identify which factors are the most important factors. And then we moved on with evaluating these key factors and what are the effect sizes based on the regression analysis. And we also looked into, since this is a global level meta-analysis, we looked into where does the maximum variability exist in terms of harvesting cost and productivity. So there was 3 geographical scales that we used, the stand, country, and continental level scales. The methodology, as I have mentioned before, it's a meta-analysis approach where we looked into deeper search for data from the published articles using keyword searches, using Google Scholar and OneSearch search engines, resulted in 439 observations from 53 studies published in 19 different countries. From these studies, we also identified 19 different variables that affect timber harvesting cost and productivity based on how they're reported, and narrowed down our search for further investigation into 5 different variables for cost and productivity. And after that, we moved on to estimating the effects for each of these variables, for which we used a linear mixed effects model in our software, which estimated and predicted the results for the regression results for each of these estimates. As you can see here, this is a representation of how the data was collected, and you can clearly see that most of the data was collected from the North American context, were also followed by the European region. There was also some data from the Asian, but if you look into the Southern Hemisphere, the data was very less. However, it is a broader representation, not based on the actual harvesting being done, but based on the literature that has been reported. Again, we used a certain selection criteria, which if you're interested, we'll be talking about more, but I'll go further into the results, which showed like a really clear trend based on these articles collected, and even within different continents, there was an increasing trend in the interest of research that being conducted in timber harvesting cost and productivity, or in general, the forest engineering. So that was an interesting result that we observed from the analysis. However, there was high variability in harvesting cost and productivity. So harvesting cost variability was highest between different stands, or at the stand level, or different harvesting operations, followed by, if you look into differences between different countries, and then at the continental level. So there's like a gradient that the variability decreased as you go for larger scales. However, for productivity, the stand was only 42%, whereas the continent variation was the highest. That was something interesting, and followed by the differences between the countries that were found to be varying for very least. We also ranked all the 19 different variables based on the importance for like the decision tree, like which all the variables are important for harvesting costs, and found out the average height of the stand was the major factor that influenced harvesting cost, followed by country, harvesting process, and harvest area, and the DBH. So DBH was less important for harvesting costs, whereas for productivity, DBH was found to be more influencing, and followed by harvesting process, for machine rate, utilization, and harvest area. So if you look into harvesting cost versus productivity, harvesting cost was mostly influenced by the stand characteristics, whereas and location, if you can see country there. And for harvesting productivity, the major variables included were the stand characteristics and the machine attributes, like machine rate and machine utilization. So that was the initial step, and then we advanced further with estimating the root mean square errors and R-square values. We used this result in the hierarchical mixed effects or linear mixed effect modeling, and used the AIC values to reduce these other results from our final regression results. So on the right bottom corner, you can see the DBH and area and machine rate indicated by dots, and at the top, the mission rate had the highest influence. And you can see on the left the predicted values for mission rate that shows there's an increasing. As mission rate increased, the productivity also increased. So that was something interesting that could be used in the future studies and research to explore more. And similarly for harvesting cost model, we found that like this average stand height was the most important factors influencing harvesting cost. And there was a decreasing trend in harvesting cost. Like as the harvesting average height of the stand could be like is a major factor for looking at the site index and the volume, which could be one of the reasons for this negative relationship. In conclusion, stand level variability was consistent in both harvesting cost as well as productivity models, and the average height was negatively influenced by harvesting cost, followed by harvesting productivity was proportional to mission rate. Comparison, so this indicates that whenever you make comparison between different harvesting costs and productivity between different operations at a stand level, all these factors need to be considered. The second chapter that I had was looking at the harvesting costs and productivity from a individual study level operation. And the objectives were to examine the harvesting costs and productivity of partial harvest versus clear cut, which also estimated the cost of producing wood chips versus cost of producing sawlog based on two different apportioning methods. So the joint product allocation versus byproduct allocation. And the joint product, if you are not familiar, the joint product assumes that the cost of producing that product will be shared at each of the operational phases, whereas the byproduct allocation assume the cost of producing a certain product is only involved if that product is being produced. So for example, the cost of producing wood chips will be only chipping in byproduct allocation, whereas in joint product, it will be the joint cost for felling, processing, and all other components involved. The estimate of, in this study, we also estimate the cost of producing sawlog chips only if there is only accounting for wood chips. And the methodology we used was a time and motion study, and the area was in northern Maine, as it was also mentioned in the previous slides. The first operation was a clear cut, which was using a whole tree operation involving feller buncher, skidder, processor, and chipper at the landing, and loader at the landing. And partial harvesting was a hybrid cut length operation, as it was also mentioned in the previous slides that a feller buncher was felling the trees, followed by a processor, forwarder, and loader. Both the stands were more similar in terms of species, the size of trees, and the composition. The novel method that we introduced in this study was an exclusive product allocation, which from a time motion study, we got the data of delivery cycle times as well as the size of trees. So we classified them based on small diameter trees and sawlog based on the size, and then using allometric equation, we estimated the small diameter and sawlog volumes, and it was then fed directly into the standard mission rate calculation method that we used, which was explained later. So this is we did it separately by separating both sawlog and small diameter trees. So it was collected using visually observed observations, and these volumes were utilized for calculating the cost of operations. So the results and discussion, I'll go over the brief result, which indicates partial harvesting was partial harvesting had 53% costlier than clear cut, as you can see here. And the extractional phase, the skidding was more productive than partial forwarding. When we look into clear cut further, we found out that the first one was joint product allocation, which was having the twice the cost, because in joint product the cost was shared between different phases, whereas in byproduct it was only considered as a byproduct. So only the cost of chipping was incurred. Whereas in harvesting, looking at harvesting cost of woody biomass within the joint product, the cost of producing small diameter trees for wood chips was much higher, not much higher, slightly higher than cost of producing saw logs. These are the two different conventional methods, whereas our results indicate that when you actually look into the cost of producing small diameter trees or wood chips only from small diameter trees, suppose if that's a pre-commercial thinning operation or if there's no saw log component, that is going to be 4 times the cost of producing saw logs. So that's going to be significantly higher than the commercial thinning operations. So the cost of producing wood chips depends on what method you're using to estimate or compare the total cost. And in fact, if it's a pre-commercial thinning operation or if it is a operation which only yields small diameter trees, the cost is much higher than the actual apportioned cost. So this method that we introduced in this study are pretty much very useful in the context of the Northeast, where we have pretty much no market for small diameter tree products, which results in undermanagement and result in the loss of products. So the major takeaways from the meta-analysis was the multiple variables drive the cost and productivity, and of which, based on the data, we found that cost was mostly related to harvesting stand height, whereas the productivity was more related to machine rate. These are the two different factors or variables that influence harvesting cost and productivity. And also at a managerial level, when you're looking or taking decisions on a stand, you should consider the stand level variables, such as the variation in machine rate, harvesting height, and all the variables that we reported for harvesting cost and productivity separately. The exclusive product allocation, the clear cutting, including chipping, was less costlier than partial harvest. Also, we introduced a new method, like I have just mentioned. This is a method that's more appropriate to be used in certain contexts where there's no market and there's huge abundance of small diameter trees, where only small diameter trees are harvested. This is a really appropriate method to use. With that being said, if you are having any questions, please put them in the chat, and I would like to thank you all for listening and being very patient for all my slides. Thank you.
Thank you.